Okay, folks. Good morning. We'll go ahead and get started on a lecture on chapter 15, and so chapter 15, how to work with interfaces. And so this is a very common concept that you'll work with in object oriented, right? Is this concept of an interface. And so we've got into classes and we've got into inheritance. And this is kind of the natural next step, is what is an interface. And so as well as working with what are called generics. And so that's chapter 15. Some of the common interfaces are kind of listed here, as well as getting into an abstract class. So first off, what is an interface? If you've been paying close attention all, semester long, we have used interfaces once, maybe more than once, right? But just because I used it once doesn't mean that you understand it. And so, I think it's, well, I can even take a step back. Why are interfaces important, right? I always like to start these lectures with why is a topic important. And what an interface is a way to ensure that your classes, now that we're working with classes, implement a certain behavior. And so what is a behavior? Well, a method. And so really what I'm saying is interfaces are a way to make sure that the classes you write, your custom classes, do certain things. Because they're going to it's going to force you to implement certain methods. And so if I look at the name iClonable, you can probably take a guess at what iClonable is going to do for you. You're going to have a custom class, and that class might be a student class. And if you implement the iClonable interface, it's going to allow you to make copies of your student objects, right? So if you have a student object and you just want to make a copy of that, right, to replicate all of the data that you have saved in that student object, right, you can make sure that your class has the ability to do that by implementing an interface. Right, so why is this important? Because again, I would just say in object-oriented programming, you get accustomed to having certain abilities when you're using someone else's class, right? So when I'm using a class that maybe one of you wrote, I might expect a toString method to return relevant information, right? So there's just certain expectations when you're working with classes to say, hey, maybe I want to be able to copy all of my fields out of an object, aka cloning an object. And so you could consider implementing this interface. And so, inheritance is one thing where you get attributes and methods from a parent, but implementing an interface is something else. iComparable, well, it's going to allow you to compare two student objects. How can you tell if one student object is greater than or less than another student object? iEnumerable is an interesting one. It allows you to loop over your objects, right? So if you have just a student class, you can't use that with a for each loop. Now, what you can do is you can create a list of students and then loop over that list. However, right, a student object itself is not something that you can loop over. So these are kind of three, what I would describe as common interfaces that you can consider putting on your classes, and that's really what this coding demonstration is going to be. I'm just going to make a class of whatever, and we're going to implement these interfaces. Now you're going to notice some of these have angle brackets and some of them don't. These angle brackets are really this second piece here with generics, and so we'll dive a little bit deeper into generics on a different lecture today. I just want to talk about interfaces. You can kind of tell the convention on an interface is with a capital I, then the name of the interface. And again, some of them are generics. If you've used a list, you've used a generic before. You can have a list of integers, you can have a list of students, you can have a list of customers, so on and so forth. And so again, kind of take this back just a little bit on the theory on interfaces. You know, what does an interface do? Well, an interface ensures that you have certain methods in your class. And there are common interfaces built into C# that you can consider putting on your classes, iClonable being one of them. And that's just going to make sure that your classes have certain features, right, that are kind of normal to have. And so now, again, there are built-in interfaces in C#, and you can make your own interfaces. And just like anything else, you could put an access modifier. So I would make my interfaces as public. Literally, just like you define a class, it's public class and then class name. You know, you define an interface the same way. So if you're creating your own interface, it's because you might want to say, okay, I want a certain set of classes to implement this method. Okay, I want to make sure that any class that implements this interface gives a more specific implementation of this method. Something interesting about this method, first off, recognize this is a method. It is a method. You can tell that because it's got parentheses. But you're going to notice there is no method body, right? An interface declares a method signature. And so what is this? This is the return data type. This is the method identifier and the parameter list. So for declaring our own interfaces, you declare method signatures, but not method bodies. Because ultimately, you're going to declare the body of the method when you implement the interface. Okay, this is just basically saying, hey, I want to make sure that any class that implements this interface, they're calling this iDisplayable, is going to be forced to write this method called getDisplayText. Okay, and again, you just kind of terminate. This is really an interesting syntax. You just kind of terminate the method with a semicolon up in the method header. That's not very normal. Now, I know that I've got a lot of gamers in my class, and so I always kind of like, if I were to create my own interface, I always like, in this chapter, we actually, pretend like there's some gaming lab, right? There's some Pokemon lab, because I got a lot of gamers. So I do like doing a lot of business applications, but for my gamer students, we do trickle in the occasional gaming lab. And so I like demonstrating this in a gaming context, this concept of an interface. Yeah.
Is this what I've been seeing on the chapter 12 lab when you list out the methods and stuff, like right under the...
Shouldn't have been on chapter 12. This isn't really until chapter 15 where we talk about interfaces.
Well, there's I was just trying, when you mentioned get and then the method something, I remembered how you put the classes and then right under it says get something.
No, that's going to be something different. And I can help you with that. Okay. I kind of, not that long ago, was a gamer myself. I don't really consider myself a gamer today, but it feels like very recent history. I played a lot of League of Legends. I even got on, this was before I was married and had a kid, but I used to get on nightly with my students and play League of Legends games. And so I really enjoyed League of Legends. How many League of Legends gamers are in here? At some point in your life? Really? 4 or 5? Anyways, League of Legends, I played a lot of junglers, and so my main was Hecarim. He was a powerful character. Anyways, in League of Legends, you've got different abilities, and every champion has different abilities. And so there were basically 4 abilities per champion. There was an ability at the Q, at the W, in the E, and the R, right? So every champion had a Q ability. And so I could make this interface called IQ ability, because what I want to do is I want to make sure that all of my champions are forced to have, because was the Q the ultimate? The R was the ultimate? Oh, we got to go with the R ability then. The IR ability. The interface for the R ability. Therefore, any champion that I'm going to create is going to implement this R ability. Therefore, it's guaranteed to have an ultimate. Okay? That's kind of the idea. All of our champions would be forced to implement this R ability. Okay? So the name of my interface is IR ability for that kind of reason. And I'm going to make now notice there's no access modifier. It's going to return a string. And I'm going to say ultimate and it's going to be, pretty simple interface, right? And I don't know that it needs to take any inputs, and you just kind of terminate it there. Now, if I mark it as public, it doesn't seem to matter. So I'm going to mark it as public. So I'm making an interface. That interface is going to make you implement this ultimate ability, and that's really all this interface is, just as a simple demonstration of an interface. Okay? Again, public interface instead of public class. The convention is it starts with the capital letter I, and then here we have our ability. Now let's go ahead and implement my class. And because we like inheritance, I'll just make one called champion. And I'll make my public class champion. And I'll go ahead and make another class that is a more specific champion called Hecarim. So this is my class for my character called Hecarim. And I'm going to say that my champion implements an IR ability. Now right away you get red squigglies when you implement an interface. And so somewhere in here it's worth mentioning, you can only have one parent that you can inherit from. Okay, that's something in C#. You can only inherit from one parent, but you can implement many interfaces. Okay, so if there was a Q ability, a W ability, an E ability, and an R ability, you could implement all of those. However, you can only have one parent. And so I will inherit from champion. So Hecarim's parent is champion, and champion implements our ability. Now right away when you do this, you're going to get a red squiggly, and it's going to say champion does not implement the interface member, the ultimate method. And so I'm going to show potential fixes, and it actually very intelligently, if you will, is going to put in a method signature that matches the interface, right? So it's a public string ultimate. Again, that method header matches my RIR ability. And this kind of throw new not implemented exception, it's kind of, do I really want to have a champion? There is no such thing as a champion. There's only actual, more specific champions like Hecarim. There's no generic champion. And so maybe what I want to do here is say, okay, no, I want Hecarim to implement IR ability here, and this is a really good example of inheriting from a parent and implementing an interface. Okay, so maybe I don't want this implementation here, and instead I want it here. Now I'll bring in my interface here, and this makes a little bit more sense. Okay, because ultimately it's Hecarim that has an ultimate, and I really don't remember the name of Hecarim's ultimate. I guess I can Wikipedia this. Anyone remember? Boy, the importance of Hecarim ultimate. Looks like the Shadow of War. Oh, there it is. Onslaught of Shadows. So this is the character, and that's what he does. Okay. So we're just going to return, and obviously if this was any sort of actual code, it's not gonna, just return a string that says Onslaught of Shadows, but you get the idea that by implementing the interface, it forces us, in other words, our code will not compile if we don't write this method. Okay? So it's Monday morning, you guys are waking up, but let's just lock this in, right? An interface forces a class to have a behavior. And when I say a behavior, that really just means it forces a class to implement a method. It forces a class to have a method. Because our champions are going to be forced to have some different abilities, we can bring this in like that. And again, how to inherit from one parent. You put the parent first, and then you put the list of interfaces separated by commas after that. If I had another interface called clonable, and this might be a good example on implementing an interface that's built in, you just separate them with commas. You could just keep that list running. Of course, iClonable is going to say, wait a minute, it says supports cloning, which creates a new instance of a class the same value of an existing instance. Hecarim does not implement interface the method called clone. Okay, so the easiest thing to do, what I typically do right here is, of course, I'm going to go to show potential fixes. The hotkey, for those of you interested, it should be Alt-Enter or Control-Dot. So let me hit Control-Dot. And then I should be able to hit Enter, and there you go. So now I've got this clone object, this little line right here, all that means is you haven't actually coded this method yet, which we know that. It just, if you don't have this little line, you're going to get a red squiggly, so they put the red line in there to kind of tell you, hey, we still need to code this method. All right, that's how we implement multiple interfaces and still have a parent. Let's do one more champion. Because I want to demonstrate something in the form. I just need multiple champions. Who was the werewolf looking guy? Warwick?
Yeah.
Yep, I kind of remember that. W-A-R-W-I-C-K, right?
Yep.
All right, so we got Warwick. Warwick is another champion. Public class Warwick inherits from champion. And so again, the language here, we're inheriting from a parent and we're implementing an interface. So the interface is IR ability. I'm going to hit Control-Enter to bring in the ultimate. And my Google search for Warwick ultimate is going to bring me to this right here. There's our little werewolf. And Infinite Duress is his ultimate. And so we're just going to return a string that says Infinite Duress. And so now let's kind of flush out a champion a little bit here. And if I go back to my Warwick Ultimate, if I just go back to this, there's like some stats, right? So health, mana, like all of these would be some generic stats that you can store in a champion, right? Because all of our champions would have health and mana and attack damage and armor. For the sake of not going into too much detail, and so I can get this, I'll just pick I'll pick like the left-hand column and kind of code that out. So I'll make some properties. Integer health, prop int health regen, prop int armor, my hotkeys fail me there, prop int magic resist, prop int move speed. Okay, so it's safe to say that all of our champions have these properties. Okay, now because of inheritance, Hecarim and Warwick are going to have these properties as well, because we've inherited them through this little line of code right here. Let's go ahead and on the form demonstrate let's override a toString. And let's maybe do that here. Override the toString, and this will say so again, because of inheritance, this is a health property that we inherit right here. And so essentially what we're doing is we're calling the get block. We're calling the get block right here of the health property that will return the health instance field. Okay, so health of this. Health regen, armor of armor. Now I don't have any constructors or anything here, so I'm going to have to use those object initializers, which is fine. Okay, so all, my Hecarim has a toString method, which will print that out. And we can now, my one thought is I could just copy that into Warwick, but the problem is then we're copying code. We're not supposed to do that. So let's go ahead and put this in champion. And then here, I'm just going to say get type. And that will at least get it to say the Hecarim is the type. Now it might say my interface demo.Hecarim, but get type will at least get it to say the champion's name or the class name. That way I don't have to repeat this method a bunch of times. let's go into the form and demo champions. And let me get rid of that button name because that's what we teach, is that we should always name our buttons button demo champs. We get good event, I should say, event handlers. And bring the designer over along with a label. Call this label result. Hecarim my champ equals new Hecarim. And we're going to use, again, so when you're creating an object, if you pass the values in the constructor, in other words, if you pass the values in the parentheses, you're using a constructor. But we're not using a constructor. We're using this other feature in C#. This doesn't exist in Java land. Okay, just in C#, you could put these curlies here, and you could do something like health equals, 620, because that's an integer. Health regen equals 4. Armor, just pulling the numbers off of the website here. Magic resist equals 32, and move speed, he was always a fast little gun, 355. Then we can do the same thing for Warwick. Warwick team mate. Is there one word? Team mate, whatever. Is new Warwick. Oh, wait a minute. This was all Warwick's data. Bada bing, bada boom. Let's go Hecarim on here, pull up his information. Not that that is important. There we go. Okay. Okay, so if I were to say, obviously my champ.ultimate, I think you're going to know exactly what that's going to do. That's going to return Onslaught of Shadows. And if I were to say teammate ultimate, that's going to say infinite duress. One thing that I see quite a bit, and I wanted to show this here. Last week we kind of learned something called upcasting. And upcasting was this idea that you can take any child object and cast it up into one of its parents. And so, like if I had a list of champions, we can go champ list dot add, and we can add my champ to my list, and we can go champ list dot add teammate, right? And we learned that this is a valid upcast. And so this, again, all these things exist for code reusability, and I wanted to demonstrate something interesting when it comes to interfaces. All right, so notice that Warwick has an IR ability, but so does Hecarim. And so you can actually, what we did last week is we actually wrote a method, private void champ demo champion C1, and we demonstrated that you can pass champ demo my champ demo teammate. All right, it's kind of the same thing going on here with lines 17 and 18 as well as 20 and 21. We're doing this upcasting, right? Child objects casted up into parent objects. The same thing kind of exists in the world of interfaces. Any class that implements an interface can be passed into a method that accepts that interface. Check this out. Private void champ demo IR ability. You can actually accept a type here. Okay, now right, so now we're getting some ambiguous calls because we don't need this twice. We had two methods with the same name. We can write a method that says, hey, everyone kind of zone in here on line 29. Any class that implements IR ability can be sent into this method. And so notice my champ implements IR ability, so you can send Hecarim, you can send a Hecarim object and a Warwick object, basically any object that implements an interface. And so if I just label result.text equals C1 dot ultimate, so I'm not really doing anything with my champ list here, so I'm going to maybe comment that out. So now I have a method that has a parameter of type IR ability, and any class that implements this interface is a valid type to be cast into this C1. Now, of course, if I'm sending a Hecarim and a Warwick, you're going to get both of those ultimates printed out. Okay, so this is another type of casting that can take place that you see very often in C#. You can upcast from child into parent, and you can cast any object into an interface that implements that object. And you're going to notice here, it doesn't really matter what champion you send into this method. This method can now execute the ultimate of whatever. If you had, just like League of Legends has 100 champions, you know, you can get one method that's going to execute whatever ultimate that champion ultimately implements. And so that's kind of, that's kind of down into the weeds of making your own interface and some of the code reusability benefits there. But let me back this back out and demonstrate an interface that's built into C# that's fairly common to find on your classes. And so here we have this iClonable interface, which will make, well, pretty obvious to me, but I've been in it for a while, make copies of an object. And so if you didn't have clonable interface, you basically need to, read all of the properties out of your object and copy and paste them, if you will, make copies of this. And so let me flush this out and what this would look like. Now, it's interesting to me that the clone method doesn't take in we'll call this H2. And so just like I did last week when now it's not going to be happy, is it? Yeah, it has to be the exact method signature. Let me So here I'm going to, this is a little bit different than what I was doing last week. So here's our clone method, and I'm going to return a new Hecarim object. And the syntax is going to be this: armor equals this dot armor, health regen equals this dot health regen, speed, move speed equals this dot move speed. And so the syntax that you're kind of seeing here, you're going to be able to call this clone method. It's going to return a new instance of a Hecarim object that's going to match the instance field of the instance object that you're calling this clone method from. So there's 1, 2, 3, 4. What's the fifth one? Of course it is what it is. What am I forgetting? Magic resist. Okay. Magic resist. This was on Hecarim. Magic resist equals this dot magic resist. Again, get out of the weeds here. Now, it's not. Let's see. I did misspell heck. There we go. What are we doing here? Okay, kind of pan back, because if you don't understand this syntax right here, it's like, what's going on? When it comes to interfaces is a new concept today, right? They force you to have a certain behavior. There are built-in interfaces into C# that are commonly used. This is one of them, okay? What this allows you to do is create these custom objects that you can very simply make copies of them. Okay, because making copies of an object and then maybe making changes, like I want you to imagine, some of these classes, our classes are pretty simple. They've got 5 properties. In the real world, you might have 50 properties. Okay, and so when you have, 2 different things, one thing has a bunch of data in it. Instead of starting thing 2 from scratch, you might just say, no, let's make a copy of thing 1. And then let's make changes to thing 2, right? And so instead of starting from nothing, let's make a copy or a clone. And so for that reason, there's an interface built into C# that interface is called iClonable. It allows you very simply to write one method to make a copy, and then you can call a clone object, and then maybe make changes. And so to demonstrate this, now one last thing is needed. Notice what the clone object returns. Clone returns type object. Now if I change this to Hecarim, it's not happy. iClonable needs to return an object. Well, that's valid because object is a parent class, so we're doing an upcast here. We're casting a Hecarim into an object. That's an upcast. That's valid. What's happening over here is it's saying, hey, on the right, the clone method is returning a type of object, but we have a Hecarim on the left. We got a type mismatch. We got a Hecarim on the left. We've got an object on the right. What do we do when we have a type mismatch? We need to cast. So we can cast our clone like such, and now I've got two champions that basically have the same stats. So this is a demonstration of implementing an interface in C# that is built in. So I've done both. I've made my own interface, and I've demonstrated how to make an interface and how to implement an interface, and kind of very important, at least for future semesters, is, hey, understand that you can write a method with a type of an interface, and that any class that implements that interface can be sent into that method, and that's a valid call, right? And then I demonstrated a pretty simple interface that you can write that basically makes a copy of an object called iClonable. Now, a couple more common interfaces built into C# that I do want to go through. I'll send you guys on a morning break, let you kind of get recharged, get a breather in before I continue. And I'm going to do a couple more C# interfaces that are just, again, kind of common interfaces that you would consider putting on your classes. All right, so let's go ahead and take a break. Okay. One concept before we continue on a little bit more with interfaces is the concept of an abstract class. So all of our classes that we've been creating have been regular C# classes. None of them have been abstract. However, going back to our code demonstration, a champion is so generic, it is so high up in the hierarchy that there's really no such thing as just a champion. The whole reason the champion exists is to be inherited from. And so if you're talking about inheritance, up the inheritance tree is generic. The lower you get more specific. You can go so high in the inheritance tree that it becomes unrealistic to actually create objects from this thing. And so you can mark your classes as abstract if you want to prevent any developer who's using your classes from actually creating a class. Okay, so all I've done in this case here is I've added a keyword, and I've now marked the class of champion as abstract. And what then again that prevents me from going in here and creating a champion object. You can see now this will be a compiler. Cannot create an instance of an abstract type. Okay, so when you're dealing with inheritance, you just have this concept of an abstract class. that says, hey, everything that I do inside of Champion is just for code reusability in these subclasses, right? We don't have to recode all of these things in the subclasses. And so that's an abstract class. And here's this slide that says a comparison of interfaces and abstract classes. Well, you can already tell abstract classes can have method bodies. Remember, on our interfaces do not have method bodies. They just have method signatures, right? So that's a big difference in that they're both kind of there for code reusability, but let's look at this. Both interfaces and abstract classes can provide signatures that a class must implement. Both interfaces and abstract classes can implement some or all of their properties and methods. An abstract class can use instance variables and constants, as well as static variables and constants. An interface can only use static variables and constants. So that's an interface. Kind of going back here, we haven't really dealt a whole lot with static variables. But if I were to just try and make a private piece of data here, int, just call it, just make it up. This is an instance field, and by convention it should be lowercase. Our instance field says interfaces cannot contain instance fields, so we have to mark them as static. And so I think this warrants just another discussion about what that means. There's a big difference, and I guess now's the time for that discussion. Instance fields versus static fields. Well, if they have the keyword static, then they're static. If not, then they're instance, and we've discussed what that means. An instance field, like student ID. Every student is a unique object. Each instance of student ID is an instance field. I think of static fields are AKA shared. And so there's one word when I hear a static field, is this is a field that is shared amongst all instances of a class. So let me kind of give you a good example of a static field. Here I could make a private private static int called instance count. And every time I instantiate a hecarim with a constructor, we make instance count go up by 1. And this is because it's static, it is a shared field across all of my objects. So instance fields are just that. They are unique for every object. Static fields are not unique. It is one value that is shared amongst all of the instances of that class. And so just to kind of go back here, when you have an interface, all of their fields, by the rule, they have to be static. And again, a class can only inherit from one parent, but it can implement more than one interface. Okay. So just to touch base on an abstract class. So if you go so high up in the inheritance chain that you cannot instantiate that thing, you can mark it as abstract. You can also go so low in the inheritance chain that you don't want it to be inherited from. And so if there's something so low in the inheritance chain, you say, you know what, this is kind of like the bottom. You're not allowed to have another child. You're not allowed to have, you can mark it as sealed. And so that's kind of, sealed is kind of the opposite of abstract. Sealed is like, nope, you cannot inherit anything lower in my inheritance chain. Okay, kind of going here, when you look at the common built-in .NET interfaces, truly we could spend a month diving into common interfaces in C#, okay? And really understanding all of the inner workings of these common interfaces. We're not going to do that in this class. It's important to understand what an interface is. It's important to understand how they work. And then the inner workings of each one, the more you work with C#, the more you work with interfaces. You know, I'm just trying to give you the foundation so that you can apply that on all these different interfaces. But I did do iClonable. I did the first one. I'm going to do the second one as well, an iComparable. And just, again, so you can see it on more than one interface. I think if you understand how it's, again, if you understand the fundamentals of an interface, what is an interface, why do they exist, how do you implement them, yada, yada, then you can begin to apply that on all these different interfaces that are out there. So let's just do one more. We'll do iComparable. So again, that's creating our own interface. Here's our Hecker room. And if you just type in again, there's a huge list. Obviously not all these. But iComparable. And again, some of these have angle brackets, which means it accepts a generic type. Some of them don't. And so I've heard a lot of developers complain that this is an annoyance, that there's actually two interfaces, one that accepts a generic and one that does not. For this example, let's just implement the one that does. Implement the generic. Now again, you're going to separate it with a comma up here. And this basically says, hey, we're comparing Hecker rooms. And so if you have two Hecker room objects, you want to compare them. Maybe you want to sort your Hecker rooms by their health. That's where you implement iComparable. Again, ultimately, this is going to work on the array.sort. When you write this iComparable, there's a compare to method, kind of hovering here. Hecker room does not implement compare to. So I'm going to hit Control dot, then I'm going to hit Enter. And it's going to bring in the signature for me. So we're comparing two Hecker rooms, and ultimately we're going to compare them by their, compare them by their health, I suppose. So if the first Hecker room's health is greater than the other Hecker room's health, now you're going to notice this returns an int, right? So we're going to return a positive value. And so there's basically three things here: greater than, less than, or equal to. Else if this dot health is less than, return a -1. Else return 0. So again, this is a method, this compare to method is going to be called by an array.sort. And so writing this compare to allows us to compare two Hecker room objects. We get to define how we're comparing them, and this can be more complex than this. This is very simply looking at one thing, the health of one Hecker room compared to another. And so back in my form, here I've got a Hecarim, my champ. Here we've got a clone. Let's go ahead and change the clone's health to be something higher. And let's go ahead and have an array of Hecarim. Passing it to clone and my champ. So we now have 2 Hecarims, and we should be able to now array.sort. And I guess just for another demonstration, let's make another Hecarim. We've got my champ clone. Let's make your champ. And let's just make your champ have a really low. So now we sort them. It should sort them by their health. There's 3 Hecarims. Let's put all 3 inside of our array. And let's loop through. Our array. And now once they're sorted, the data should go in not sorted, right? So we got 600, then we got 700, then we got 100. So the sort should put them in a different order. Again, let's put my champ in first, then let's put clone in, then let's put your champ. So they're kind of going in this unsorted order. We sort them, and Hecarims sub I dot toString, and let's see what's broken. Compiler error here. Need a semicolon. Okay, let's put in a line break on our toString so that plus equals. So over here, let's do plus equals, third time's the charm. Aha. And you can see, even though that's not the order that we put them in, it's sorting by their health, right? So we got Hecarim has a health of this, and they all have all the same other data, but it is in fact doing a sort. And the reason that is working is because we implemented an interface called compare to. So again, just kind of like, surface level, what are we getting out of all of this? Well, there are some built-in interfaces that provide some common features that you can put on your classes. Making a class clonable, making a class comparable so that you can sort by some sort of manner. Because when you have a generic thing, there is no default way to sort all the things in the world. You have to define how to sort the thing or how to compare the thing. And that's what you get out of these interfaces. Right? iDisposable, iNumer, these are kind of fun when you get into like making your own collections. A lot of times I don't really cover this in detail because we've got a great collection called a list. And so instead of making your own collections, you're just going to use a list. Like realistically, you make a list of your things. You don't need to make your own collection of champions because you just have a list of champions. You don't need to make your own. So we covered that, covered that. All right. I think that's where I'm going to stop for today. Not that that's all the theory in this chapter, but it's a good introduction. What I'm going to, again, custom lists, what I want to cover in a little bit more detail is generics. So I need to cover generics in a little bit more detail in another lecture, and I will do that after we get some labs under our belt.